Here we are on page 2, and example 1 says, at a restaurant, you have a choice of 8 different entrees, 2 different salads, 12 different drinks, and 6 different desserts. How many different dinners consisting of 1 salad, 1 entree, 1 drink, and 1 dessert can you choose? So if we have 8 options for our entree, we're going to multiply 8 times our 2 options for salad, times the 12 options for drinks, and 6 options for dessert. So when we multiply that all together, we get 1,152. So we could have done a very large tree diagram. That would have taken quite some time. This fundamental counting principle helps us do it quickly. Example 2 says, how many different 7-digit phone numbers are possible if the first digit cannot be 0 or 1? So we have a 7-digit phone number. The first number can't be 0 or 1, but it could be 2, 3, 4, 5, or 6, 7, 8, or 9. So 0 and 1 are out. There are 8 more options. So we have 8 options for the first digit, but we have all the options for the rest of the digits. So we're going to take 8 and multiply it by 10 times 10 times 10 times 10 times 10 times 10. So how many different 7-digit phone numbers are possible if the first digit cannot be 0 or 1? So we multiply that all together and we get 8 million. And when you throw an area code in there, we have a lot more options. Now we look at factorials. A factorial is a function that gives the number of ways of arranging objects expressed as n with a punctuation mark. This exclamation point is here. It represents factorial in math. So a formula for a factorial is n exclamation point. We're going to take the first number n, and then the next number is n minus 1. So they're just decreasing by 1 each time. So our example, 5 factorial is 5 times 1 less than 5 times 1 less than 4. So 5 times 4 times 3 times 2 times 1. There's only one special case for factorials, where 0 factorial equals 1. It's usually used in some proofs. So what's 3 factorial? Multiply 3 times 2 times 1, and we get 6. We're going to need to know this factorial when we look at permutations and combinations. So the first of those is permutations. So I'm wondering, how many arrangements do we have here with Tom and Jerry? Tom and Jerry is one option, but then the reverse order, Jerry and Tom, is another option. So these count as 2 permutations. Here order matters. Tom and Jerry is different than Jerry and Tom, because it's in a different order. So permutations, order matters. A permutation is a function describing the number of ways the n objects can be arranged in order. What helps me to remember that permutation needs to be in order is that if you use a phone number, if you mix up that phone number, you are going to be calling the wrong person. So both permutation and phone start with P, so maybe that will help you remember it. Our formula for permutation is n factorial over n minus r factorial. So in this first example, if we have 8 with a permutation of 3, I'm reading that right, we have 8 factorial, our n is 8, and our r is 3. 8 factorial over 8 minus 3 factorial. That is going to be, change the color, 8 times 7 times 6 times 5. 4 times 3 times 2 times 1, and 8 minus 3 equals 5. So we're going to have 5 factorial. 5 times 4 times 3 times 2 times 1. So both in the numerator and the denominator, we have 5 times 4 times 3 times 2 times 1. So they can both cancel out, and we're left with 8 times 7 times 6. So in this problem, 8 times 7 times 6 here, we get 336. try example 2. 5 factorial over 3 factorial. I got the 3 from subtracting the n and the r. So if the 3 times 2 times 1 is going to cancel out on both the top and the bottom, I'm just going to be left with 5 times 4 on the top. So in this example, our answer is 20. So remember, for permutations, order matters, and each different order represents a different outcome. In example 3, there are 12 books on the summer reading list. You want to read some or all of them. In how many orders, keyword here, orders, can you read 4 of the books? So our n will be 12, and we're choosing 4 at a time. So our r is 4. So we have 12p4, which will be 12 factorial over 12 minus 4 is 8, 8 factorial. 8 and lower will cancel, so we're going to have 12 times 11 times 10 times 9, which is 11,880. Now we can do this in the calculator too. I don't have a calculator on my screen here, but if you find your math button, which is underneath your alpha button on the left-hand side, scroll over or hit your right arrow 3 times to get to PRB, which stands for probability. And then we want to look, in this case it's option 2, it tells us N, P, and R. So in your calculator, you would want to go to the home screen and put in the 12 first, then go through this process in the calculator, and have the 4 at the end. So this 12 P4 will be what your screen shows, and if you just hit enter, it'll tell you right away your answer is 11,880. Now we're going to move on to page 3.